thank you everyone for coming here. So today I'm going to talk about how to efficiently share and manage secret across applications using HashiCorp Vault. As Kelly mentioned, my name is Mizan, Rahman. I am a cloud architect and DevOps expert. I have experience in the large insurance company and also in the banking industry. And this talk would be kind of a follow-up talk that we had this morning, the SAP team shared in the Rahman's keynotes. It will be a follow-up talk like on how to use this in the industry, how we are using Vault effectively and efficiently to store secrets and managing and sharing them. So with that, let me start here. So in the enterprise, we have a lot of applications. It's called back-end applications that you need secret to access that. So those back-end applications, you can think about MongoDB or Splunk. So there's a lot of the applications on the back-end applications, but if other applications wants to access them, you need a credentials for that. Typically, these credentials are generated manually and then stored somewhere stored them in the plain text manually also. And those credentials are shared through emails, right? Somebody sending in emails to somebody generating the credentials for these back-end applications, send an email to other consuming apps, and then stored into somewhere in the plain text. So the discussion today is how do we use HashiCorp Vault to effectively share these backends application secret with other apps, consuming apps. So that is the talk here today. So this is a simple examples here, like what is the backend applications? This is backend application means the application that provides some functionality for other apps. And then, for example, I listed here something: database, MongoDB, Postgres, logging services, Splunk, App Dynamics, and also we have a monitoring service, Prometheus, Grafana. All these are. And you might have this list of in a large enterprise, you might have the hundreds of them. The Prisma. There's so many applications, back-end applications. Those are used by just regular application. So consuming applications can be a Java apps, any Java apps you would develop, with Python apps, React apps, whatever we are developing applications, they consume those back-end apps. But to consume these, to access those back-end apps, you need credentials. And those credentials are usually form of typically in API keys or passwords or tokens or certificate. These are usually the types of credentials you need to access those backend apps. And as I mentioned, they are usually sent through the email to the other consumer apps, and so that they can store it. But what they do, instead of what they're storing when they get the email, they store into the Confluence space or they store it in the GitHub. So why they put it in a Confluence space? You can think about they're storing the Confluence space if you're in a non-prod environments, lower environments. You might have a Dev 1, Dev 2, Dev 3. You have a Seat 1, Seat 2, Seat 3, so many environments. And at that time, they put it in the Confluence so that it can be shareable. It's supposed to be Confluence should be managing your knowledge, basically sharing your knowledge. Instead of that, we use typically in the enterprise they use the Confluence to share the passwords in the non-prod environments. Also, other places we have seen that this is also stored into the GitHub. And in the GitHub, those are also storing these passwords into the GitHub plain text, simply. So what are the issues of the security risk of doing this? So when you're sending an email, your password or your API keys or your certificate, this is very vulnerable. You're basically exposing yourself for the phishing attack or man-in-the-middle attacks or in an email breach. So that's sending that direct email directly. Those are the type of problems people will face because you're exposing yourself. And then and I mentioned that putting in the Confluence space is for sharing the knowledge, but you start putting them for non-prod environments. Typically prod environment is not there, but when these teams are sharing, they share for non-prods so that everybody can use them. And then storing in the GitHub is another challenge always, right? You start putting this in the GitHub. When you put into the GitHub these passwords, it is a huge challenge for an organization to find out what passwords are there in the GitHub. And you basically have another tool employed, a check mark. You put the check mark, and then you find false positive, And then you have to have 2 or 3 people finding out and resolving this false positive. So this is an everyday challenge. We start seeing them in the enterprise today, that when people are putting these passwords or credentials into the GitHub, then eventually our enterprise has to go through and look through and then find out what are those, and so that there is no security vulnerability. So how do we reduce this risk? What are the options, right? There's 4 options, 4 things needs to happen here. First thing is you need some vaulting solutions. Instead of storing them, you need some sort of vaulting solutions that is that can manages your passwords securely. So that's where it comes to the HashiCorp Vault. The HashiCorp Vault is a solution where it can put these secrets, but at the same time also, whenever these secrets are shared for the back end, you also need to implement the encryptions. So that means whenever you're sending the secret, that secret needs to be sent securely, and when you're storing, that also needs to be encrypted, both. So this encryption is necessary when your back-end applications sending their secrets. That needs to be secure. Other thing is also we need to find out the access control. Who can access these secrets when you put this into the HashiCorp Vault? This access control become important, and then I mentioned that 2 parts of the access control. One is authentication and authorization. So authentication means you need to log in, and usually you define them. I mentioned earlier there might be some environments, the non-prod environments and prod environments, and in the non-prod you have a multiple. In these cases, you might define some of the LDAP groups, and using the LDAPs, you identify who has an authentication to the production group or non-production. So you have to define those LDAPs authentication methods so that those right people can access to the right area. Another thing is authorization. So all the LDAP groups that we mentioned, then how do they get into this vault? So at that time, authorization becomes important, and in these cases, you will put some policy around it. So using the policy, you define them. Okay, so these groups, LDAP groups, might access to this area, the non-production area, and maybe this group, other groups, they can do a production area. You might divide that way. So the authorization authentication is also essential at that time, and Vault also has those solutions in the built-in that can be used. So next, this is great. Let's see, we have a solution now with this back-end application have passwords, and we already discussed that it's in a plain text is not a good thing. We need vaulting solutions, and in the vaulting solution, we put this password, we can put this password into vaulting solutions, and who can access using authorization, authentication, we discussed this. But the next comes to the picture, how do we send those back-end application to these vaulting solutions? How do we do that, right? We mentioned that earlier with the email methods. So now we can do that instead of directly emailing, we can email them. Like now other back-end applications admin, they can generate this password and then email them to the consuming applications admin using secure email. So the one method that you can basically get through the secure email. And we have seen that in the industry is heavily used this. So all these passwords are sent using the secure email. That's one method that can be used. Other option can be when the backend admin has direct access to the HashiCorp Vault's area for the other application consuming apps, and it can directly write into that area. So let's talk about these 2 methods. Like this is basically how I'm transmitting the backend's application secret into the consuming apps area. So let's go and look into these both areas. So issues are like, what is the issue with the backend app sending the credentials via secure email? So if that backend application admin is sending this to the secure email, the email security risk is still there because, although you mark your email as a secure, but your if server is exposed, then still your secret is vulnerable. That is one thing. Human error. This is a huge one for any of the enterprise. The human error means you send them securely, and I introduced you guys earlier, there was a non-prod and prod environments. Usually non-prod is for the developer, prod might be for the operations team because you might have a separation of duty there. So if that is the case, the operations team may not know exactly how secret works and what are the type secrets, how does it work. So when you when this admin, backend admin means your MongoDB admin send the password to this operations team who doesn't know how this whole process works, you send them the email, And secure email, they have to grab it, and they have to type into the HashiCorp Vault, and they make so many mistakes. At that time, we ended up seeing all the production failures. And then you stand up, you basically stay there late, and then debug all this, what is going on, and eventually find out these are all just simple human errors. So this type of error we have seen so many times, and that causes a big organization, large organization, a huge problem. And at that time, no encryption is storage. At that time, what happens, although you send this email in the secure email, but whoever is storing that from that email to the vault, at that time, they might put those secrets into their machine, in their own machine, local machine. So eventually, storing somewhere in the local machine is also risky. Then you're very vulnerable at that time. And the last problem that we have here also, delay in secret rotation. This is still a manual process. Although it's secure methods, but it's still a manual process because whenever you're delaying it, you need a secret rotation. You just write a ticket to your Mongo admin team that, hey, generate a password, and send secure email to your application admin. And then when you write another ticket there, so it's almost a weak process. So that is another problem with these methods there. So what is the next one? We talked about issue with the backend app, right? Other thing we can do, basically, the backend app admin directly write in the HashiCorp Vault. So this is another interesting concept that can be also deployed. Backend app means a MongoDB Splunk. They directly write into the HashiCorp Vault for a Java applications area. They write them there, and that can be basically another option. But what are kind of the issues we face with that methods if we do that? So if you can think about MongoDB admin writing secrets, MongoDB, like another 1,000 applications in your data center who need a Mongo access. So MongoDB admin is writing this one application secret to 1,000 other applications area into the vault. That is a huge no-no for any organization. Because at that time, direct access to you write access to other people's area into the vault. That's a huge risk, potential risk for the organizations, and it's a violation of the policy most of the time. So access control violations is also same thing, because you are access control violations. You may violate the policy access control policy. Lack of auditability, basically, how do you check who is writing them in the vault? That is a problem also. Like, if the MongoDB admin is writing into the vault, other applications, nobody knows when they are writing it, how they are writing it, when they're updating it. That becomes a challenge. And then also they can override some other secrets because they have write access now. And this is also is a lifecycle management. The rotation, expirations becomes challenging because you don't know, application team doesn't know when they are doing that. So these are all challenges also with that approach, right? So there's both approaches, means transmitting through the emails, it has a lot of issues. Giving access to directly from admin team, like backend admin team access to the applications team, write access is also a huge challenge for them. So what are the alternates? What can we do here? So there is a couple of alternates I can talk about here. Alternates is a built-in solution for HashiCorp Vault. You can see that is dynamic secrets, right? HashiCorp Vault has dynamic secrets built in. So in the enterprise, large enterprise, you can use them. And I'm talking about the advantage and disadvantage of the dynamic secrets here. So dynamic secret, how does it work? What is the dynamic secrets? Basically, it's automatically generating the secrets. So HashiCorp Vault will go and automatically generate secrets for MongoDB. And then basically, whenever the application comes to the Vault, and then Vault will generate the secret for you, going to the MongoDB, generate the secret, you go there, use them, you take them and use them whenever you're running them. So anytime you need secrets, you can come to the Vault and then say, hey, can you give me the secret? Advantage is basically this is a short-lived credentials. That means you can configure them short-lived. Every time you need them, you can grab it and use them, and it is gone, it's over. So there's a less security risk, less security. And then another thing is automated rotation secrets. So automated rotations, if you want them automatically rotated, they can do that. HashiCorp Vault team can do that. This is also another rollback access control. So RBAC it can be implemented with the RBAC. Who has access to what? And then secure retrieval process, right? This is a retrieval process is very secure using the RBAC that we mentioned. So whoever has access, that LDAP groups we mentioned, you can integrate them, and using that, you can automatically retrieve them using the RBAC, whoever has the access there. So we talked about benefits. Whenever you have a dynamic secret using in your organization, if you use them, it eliminates all the problems of hard coding credentials, right? It is automatically generated. There is no hard coded there. It's enhanced the security because it can handle the expirations and revocations. It's quickly TTLs is there. Reduce the human involvement. There is no human involved at that time, and then reduce the human. Improve the accountability and then compliance, because at that time your organization compliance you can implement into RBAC's compliance, and you can follow the methods. And you also have a centralized place, all the centralized management area using the dynamic secrets for all your backend services that is used dynamically rotate the secret. I think this is a built-in feature in HashiCorp Vault that is very valuable and usable for any industry, any of the company. This is one of the very valuable features that we find is valuable for the enterprise. So what are the drawbacks? Oh, sorry, before the drawbacks, I wanted to mention in one quick example. For example, here, if a Java application need a MongoDB password, so the Java application can go to the Vault, and using the instance of Kubernetes and service account authentication methods, request the database password, MongoDB passwords, and it generates the temporary passwords, and then it generates a TTL. With the TTL, it generates this token, and using that, the application can access the Mongo. This is just a quick example I showed. The reason I showed an example because this dynamic secret also has some drawbacks. What are the drawbacks that we identified or we find in there that people uses that has a dynamic secret has? So one first problem we identified on the dynamic secret was admin permission for the backend services. So let's see, Vault needs an admin permission to MongoDB or Splunk. Wherever it is there, if you wanted to use the dynamic secret, the Vault has to get this admin permission. And unless you get the admin, you will not be able to generate the dynamic secret. So this is having an admin permission is not, sometimes in the enterprise, they don't allow the teams, like there's a large team for Mongo, there may be a large team for Splunk, there might be a large team who is managing all these, Grafana. So these teams may not allow the Vault to generate the secret dynamically for them. So that enterprise may not basically allow them to do that. That is one of the challenges. But this is not a Vault issue. This is the enterprise issue, right? How the enterprise policy works. And then, increase the complexity in setup. So as I said, you need some authentication methodology for these dynamic secrets. So it might be a little complex to set up, but once you set up, is advantageous, but maybe a little complex to set up there. So another thing is you're dependent on the Vault at that time. If Vault is out, then you cannot grab the secret for dynamic secrets, and then you cannot connect to your MongoDB. I'm picking on Mongo today. So Vault is out means we have seen, there might be an option like you have issues with the transit, and then your Vault server may be out for a couple minutes or a couple hours, and then that couple hours you will not be able to access your database. So that is a potential risk if Vault is out. You have to have a highly available solution at that time, because you're dependent on another tool for your application to access the backend application. And then you also need to understand how you're handling the secret expirations. The secret is expiring, especially if the application is running for a long time, and suddenly in the middle of the application is running, the secret is expired. How do you handle them? You need to build in solutions around these dynamic secrets. And then other thing I also wanted to share that use dynamic secret, you need it dependent on your external authentication methods. So you are dependent at that time some authentication methods. I mean, earlier slide I mentioned, you might be relying on the Kubernetes methods or some cloud authentication methods at that time. So if those authentication methods are not available for the Vault, you're also out of luck at that time. It's not only Vault availability, those authentication method needs to be there, and those authentication method is out, you are in jeopardy kind of accessing your backend application. And another thing I also mentioned that not all the backend application has support for dynamic secrets. For example, we have a Mongos, there might be some So there might be 5, 10, 20 applications. You can use the customs. But in your organization, if you have 200 backend services that are consumed, in the large organization, there's even more than 200 backend services. So not all of them has dynamic secrets support from the HashiCorp Vault, because not all of them can rotate the secrets for them. So at that time, you cannot use the dynamic secrets. So what are the alternates then we have? So if we cannot use them built in, what are the alternates we have? Let's talk another methods that we find very usable, and that is basically is utility-based solution for security managing secrets. So what are the utility-based solutions? At that time, what do you have here I'm showing in the picture here, you have a backend service, and you use an utility, and you also have a HashiCorp Vault. So this utility, the simple utility can do, it can go to the backend service for an application. For example, if it is a Java application, for the Java application, this utility can go to the backend service Mongo, and it can generate password only for that app, not for any others. So it generates the password for only that app, Mongo apps, and then eventually grab it and write it to the HashiCorp Vault in the area of that Java application, nowhere else. So at that time, utility has only limited access to the Mongo, and at the time, its own credential generation capability, and it also has access to only writing into the HashiCorp Vault its own path, secret path area. So this utility is a simplified option, and this basically is dedicated for one application, just for one app, this utility. And this can be scalable. If we need another app, or same app needs another backend services, like in Mongo now, and it's in Splunk, it can use the same utility and go to the Splunk. And it can go to the next one. So this utility can be scalable based on the application, backend application, number of backend applications. And you also need who are there, like who is consuming apps. If your number of consuming apps is more, then you can also increase them. So it becomes a scalable solution at that time. And each individual level, they are working on individual level in both sides, in the backend and also HashiCorp Vault. So let's go and look into what are some of the advantages here. So automated secret generation. So we talked about that this backend application can generate secrets automatically. There's no human involvement anymore. It can generate secrets from the backend applications for any of them. It can be a Splunk, it can be MongoDB, it can be any other databases, or either Grafana, Prometheus we mentioned. It can generate secrets for individual application itself. And then direct access to the vault means that it only access to this own area into the vault, this utility, and write them there. This is also important that rollback access means basically whenever we mentioned earlier that LDAP groups, we define them. So using these LDAP groups, like these rollback is also control them where you can write. So this is a check also from there that using the rollback in both sides, in MongoDB side or in the Java app side, both sides, your rollback is there. That means you have a control using the LDAP, and using the LDAP, you can control them what the capability they have. So that rollback can be integrated into this utility, and that would be that can control the password generations and password writing into the vault. And then it can be a scheduled secret rotation. This utility can also schedulely rotate the secrets. Another thing I wanted to mention, this is very important in this area. If you have an utility, that utility can be integrated with your CI/CD pipeline. So that means the utility can run inside a step of a pipeline. So that means whenever you're deploying an application, and if you have a CI/CD, like CI/CD anywhere, initial CD deployment, you're using Jenkins, or you're using Harness, or using UCD, or whatever the tools you're using for the deployment. If you have this utility and you can add them as a part of the steps, then you can add them there. Then you also get more potential access control, because that utility, the deployment tool itself had those control who can access the pipeline. So then you have a double control there in the pipeline control, and then you also have LDAP in both sides. In your both sides means Mongo side or Java side, generating these tokens and writing the tokens. And then if you have this utility is part of this pipeline, then when you are accessing the pipeline, that is also a control. So that means you are not running this utility in your laptop everywhere, like whenever you're going and you're coming to the conference, you're writing there and then changing the password. So that these 3 levels of controls also this utility can provide. And that is one of the huge advantages that we have seen of the utility. And then if this accountability and the logging, if we can integrate a logging mechanisms with the utility, you have to do that. If you do that, then you can also find out who write them, and these logging mechanisms there, you can connect this utility to an Splunk and see that who wrote them and how this has been, who has been writing this through the pipeline. That's possible. And error handling and alerts, basically this utility has to basically make sure that it can handle the errors. That means if there's any issues happen, if it's accessing, it's not able to generate the password for Mongo, or it's not able to write in, that error handling can be integrated into there, and then it can generate an alert for you. So this capability you can add on this utility that eventually is easier for you to see what happened. And the security compliance and audit, one of the advantages of having your own control utility is you can integrate your organization's policy. How your organization wants, like you want to generate recorded credentials, you want like a big long password, this utility you can add them, and there you can add all these organization policy. So that means you can add all your own policy necessary for your organization. So you have a more control on your side. So that is one of the huge, these are all the bunch of advantages that we have seen, that your own utility controlled heavily in both areas, in the generating the secret, writing secret in the vault, at the same time running them into the pipeline, wrapping in the pipelines, for example, in Jenkins or Harness. That gives a lot of control over this sharing the passwords. And not only that, you can add more capabilities, like, for example, adding policies, adding error handling. You can add them into your utility. So I think we mostly talked about this. This utility reduces a lot of things. There is no human error. You're not typing anything in anywhere. Same thing as dynamic secrets. This utility also is centralized management. We talked about this is also centralized. And then is improve the DevOps workflow. It can integrate into the CI/CD. It's cost efficient and it's scalable. I also mentioned that this is very scalable. It scales with your backend app. Like if you have one Java apps, you can use the utility, and then you can do the multiple of the backend apps. It can be a Splunk, it can be Grafana, it can be your databases, or whatever is needed. And at the same time, if you have more apps, you can scalable. This is a very scalable solutions that we have seen. And minimize the risk. And so we find it very advantageous for the organizations, this type of utility development and sharing them, generating and then writing the secrets for. What are the potential challenges with this? Potential challenges also at the same time, utility security. As I said, this needs to control using the organization's policy. If we don't do that, and if you start writing this, using this utility on your laptop, personal laptop, then it just become a problem again. So I think the utility security is becoming important. This utility also must have to have the fault tolerance. Like if you wanted to update a secret and you cannot do that, that alerts needs to be there. If it's not, no alerts is there, then it becomes you don't know what's happened to there. It becomes very challenging. And then you also need infrastructure when you are running them. So infrastructure is also important, that you also need to find out what kind of infrastructure you are running. If it is running in the containers, the container needs to be available. And your are you compliance with your organization policy is important. That you need to also add them. So in the last thing I wanted to mention them, dynamic secret versus utility. Which one you should use? Like it depends on your organization and your needs, and it depends on the scalable, whatever the scalable solution you need for your organization. Both are very good solutions based on your needs. But if you need a more scalable solutions in both sides, we find the utilities advantageous. And if you need, if you have hundreds of backend solutions that may not have dynamic secrets, then utility may be advantageous. But also at the same time, dynamic secrets is a great solution for any organization. So we find both solutions is very compelling and very appealing to the organization. But it depends on, as I said, I talked about both pros and cons. It depends on your needs of your organization, scalability. With that, thank you very much. And if you have any questions, I'll be around here. I really appreciate you listening.